What we wanted to see is if a higher concentration of iron proliferates the growth of Clostridium perfringens, or C. perfringens, in chickens. C. perfringens are in all of us. They're inside you, right now. What matters isn't that it's there, it's how much of it there is. If there's too many C. perfringens, they begin to produce toxins. Specifically in the strain we're studying in our chickens, a toxin called NETB. NETB is directly linked to a disease called necrotic enteritis, a bad inflammatory disease that can destroy the host's intestinal tract. There have been many factors linked to necrotic enteritis, such as environmental factors, nutrition factors, and even stress, which, who wouldn't be stressed if there was a disease going around that affects 40% of commercial flocks and costs roughly $6 billion a year in losses, right? But what if there was a factor no one had connected yet? What if the very soil that we get our chicken feed from is a causal factor of this disease? See, soil on many of these farms is often rich in iron. So rich, in fact, that the recommended iron intake for chickens is 80 milligrams per kilogram of feed, but they usually end up consuming more than double that. By itself, that isn't necessarily a bad thing. In fact, there are certain health benefits to consuming extra iron. However, if it does proliferate C. perfringen growth and is a factor in causing necrotic enteritis, then we now have a solid direction we can take to lower mortality in flocks around the globe. So we made 4 treatments. One of them is what I call a hard control, which is just PBS. A treatment of non-C. perfringens to hosts to compare to the other treatments with C. perfringens. The second treatment is a soft control, a treatment injected with C. perfringens but no iron. The other 2 treatments are injected with C. perfringens and iron sulfate, one of them being a 10 microgram dose and the other being a 30 microgram dose of iron sulfate. We wanted to do something that's never been done before while studying C. perfringens. We were going to run the experiment on chicken embryos. We inject the different treatments into our eggs. Then we do a necropsy after 2 days to take the samples of the ileum, spleen, and bursa of Fabricius. And you know what? Just so we can measure the NETB and the gDNA, let's take a little bit of allantoic fluid too. After we've done that, it's time for the mRNA extraction process. Once the extraction process is complete, we take it to the nanodrop machine to measure the concentration levels of the nucleic acids and the proteins. And then we do cDNA synthesis to measure all those pesky immunoglobulins. As you can see, there's a stark difference visually in some of these samples already. We haven't gotten quite to the stage where we've retrieved the data needed to support our hypothesis, but even just visually from what we've seen through surface level observations, I'm hopeful that we'll find something through this. Until then though, I'll leave you with bated breath. Be sure to stay tuned. There's more to come.